Hello, listeners, and welcome to another episode of Cognitive Dissidence. As usual, I'm your host. I'm Jacob Shapiro. I'm a partner and the director of geopolitical analysis at Cognitive Investments. Joining me on the podcast for the second time is Daryl Ritchison. Daryl is the director of the North Dakota Agricultural Weather Network at NDSU. When he first came, I'm willing to call Daryl a friend now. I hope that's okay with you, Daryl. When he first came on, he was just a weather guy that I knew, and now I'm willing to call him a weather friend that I know. But thanks for coming on, Daryl. Listeners, not a whole lot of housekeeping for me. If you want to, I alluded to the natural gas projection that we have here at CI. If you want more information on that, about our research and consulting services, about our wealth management services, please email me at jacob@cognitive.investments. If you also just want to give me a book to read or tell me I was wrong about something or have suggestions for podcast guests, really anything, you can email me there too. Last but not least, I will be taking a rare week of vacation starting next week through the 24th. So we are trying to stock as much content and as episodes as we can so that you don't miss too much of the cadence from us. But if things slow down a little bit here, it's because I need to recharge and take a little bit of time on the beach. So that's going to happen next week. But like I said, I'm trying to get enough content recorded for you so that you still have things from us as I go to the beach and lock my phone in a safe somewhere and don't look at it. So other than that, I hope you're all staying cool. I hope you're all staying healthy. Cheers. See you out. Cognitive Investments LLC is a registered investment advisor. Advisory services are only offered to clients or prospective clients where Cognitive and its representatives are properly licensed or exempt from licensure. For additional information, please visit our website at www.cognitive.investments. The information provided is for educational and informational purposes only and does not constitute investment advice, and it should not be relied on as such. It should not be considered a solicitation to buy or an offer to sell a security. It does not take into account any investor's particular investment objectives, strategies, tax status, or investment horizon. You should consult your attorney or tax advisor. One of my personal favorite guests to have on the podcast, Daryl. Welcome back. Thanks for joining us.
I thought after the last time, I wasn't sure you would ever invite me back, but I am very glad to be back. This should be fun.
Oh, you're on the regular roster now. Careful what you wish for. I wanted to start with sort of a broader macro question. I think I know the answer to the question, but I'm curious to see how you dance around it, which is if you just look at headlines for weather just from the last 24 hours, you'd think that civilization is collapsing. We've got record temperatures in Death Valley, like a third of the US is under a heat advisory. People are dying in the streets of Japan from heat stroke. China's super hot, Europe's super hot, everywhere is super hot. And I guess the question I wanted to start off with was more meta. Is it that hot? Are things really that bad compared to relative historical baselines? When you look around at weather, both in the United States and the world, do you have the sense that, oh, wow, this really is crazy, this really is unprecedented? Or are we just paying more attention to it? Like, how do you benchmark all of these headlines versus a career spent actually thinking about this stuff?
Oh, most of it's hype, overly blown. For instance, I think it was 1950s, either 50 or 52 this week. Almost all the United States was above in triple digits, for example. Massive heat wave over the United States. And probably in the local newspaper, you'll just get, wow, it's been really hot lately. It'll cool down. And also, some of the temperature records, you have to remember that most temperatures now are kept at airports. And there's these things called jets that fly right next to the the sensor that's spewing out. I don't know what the exhaust temperature is. Must be in the hundreds and hundreds of degrees. It's outside my expertise. Not that far. And a lot of these sensors are under pavement. For instance, where I live in Fargo, North Dakota, the temperature sensor at the airport, because they don't want to clear out the weeds, they have a whole bunch of rocks right underneath the sensor so there's no weeds. And literally 10 yards away is black pavement just sitting there. Is that how temperatures were kept in the 1950s, let alone the 1880s? No. And so a lot of this adds literally 2, 3, 4 degrees Celsius to the temperature. And so they're really not reading the temperatures as well as they did in the past. We have massive urban heat islands that most humans now live in. And so it's going to be a little bit warmer. So I'm a big apples per apples person, and we're not doing apples to apples from 100 years ago. It's just a completely different world. So a lot of these people, it's the moment in time, and it's summer and you get hot, but I can find you I could talk for 5 hours and tell you back in the past where very similar things have happened before. I personally, I've been doing this for 35 years, don't find it unusual at all, but it's the headline of the moment. It's the era that we live in. It's social media, 24-hour news coverage. We have to talk about something, and just saying, hey, everyone, it's summer. Guess what? It's hot outside doesn't get you any clicks.
Yeah. Are there any parts of the world or any of these heat waves that are particularly interesting to you? I mean, it's like I saw the temperatures in Spain, for example, and that seemed kind of crazy, like 50. They were even talking maybe 60 Celsius. I mean, that seemed out of this world. Are any of them notable to you?
World breaking. I mean, it's mainly, 40 C, and then everything else is someone measured a thermometer in the sun, and it shined it up into the sunshine, and it said 55 C, but the air temperature is not that. Or, people fry eggs on pavement, and the pavement's 170 degrees, and your egg will start sizzling. Again, it's black pavement with the sun. But again, even in Spain, you can go back. I was on Twitter this weekend, and someone from Italy, of all places, commented on the heat and said, wow, I remember when I was a kid that we were 40 C all the time, and we just loved it and could, play in the water. And that statement had a lot of truth to it. It's just, again, I see personally, and this is, again, Daryl Ritchison. If you want to end up after this podcast, someone emailing me and say, Daryl, you're crazy, that's fine. I just don't find it unusual in the least. When you equate the way temperatures are taking now, massive urban heat islands, which add, again, anywhere from 2 to 4, if not more, degrees Celsius, you're going to see some of these temperatures. But again, some of the craziness isn't necessarily air temperature. It's, them taking the temperature in the sun or something just to make the headlines.
Yeah. Well, let's dive in a little bit. So let's first talk about, well, I'm debating whether we should talk about it. Well, let's leave the elephant in the room for now. I know that you, like me with geopolitics, you're constantly doing models at the beginning of each year and rechecking them and trying to figure out how things are going. At least for the United States, how do you feel about your predictions so far for the year? Are they on track? And what do you see in store for the remainder of the year?
It's been, I'm sure it's in your line of work too. A lot of times, and I think you can relate to this statement, and people laugh at me when I say this sometimes, I'm right, but I'm not right. Everything's going, it's just placed a little bit in different scenarios. It's, I had this area wet, but it ended up being wet maybe 150 miles away because it's into perfection. So my general idea worked very, very well, but it never works for everybody. And I'm sure it's the same for you. Weather is a chaotic, nonlinear system. And so you're never going to get a summer forecast perfect. I'm looking at the general trends, and as what I'm doing useful so someone able to use this and have a net, economic advantage, or there was a value proposition into what I'm saying. And so, my general thoughts were pretty close, but, last year my stuff was so good. It sounds arrogant, but boy, I told people I will never be as good as I was in 2022. It worked out so well for just about everyone. And this year, I'm probably 70% good, 30% it just didn't quite work out well. And of course, you have to make a few adjustments. But, considering you're doing sometimes a 6 to 9 month lead time projection on things, I thought, it worked pretty well. Most people, it's always amazing if you're right, and I'm sure you can relate to this too. When you're right, no one tells you you're right. It was just expected. And so the people that I had a really good summer for don't say anything to me like, hey, Daryl, I thought your stuff was going to rain more this year. It hasn't rained at that kind of stuff. And I go, hey, there is no doubt you are right. Your spot, your county, my forecast didn't work well. But guess what? 60 miles from you, they're throwing money at me. They're so happy, not literally, but they're really happy. So I mean, those things happen. But again, I'm satisfied. And, the thing that I really appreciated about this year, which goes into really, I think the topic we'll get to here shortly, is that people, we transitioned from a La Nina to an El Nino. And so people were just thinking, well, this is what usually, and a key word there is usually, is a code word there for me, is what happens. And even this past spring and winter, I would always, in so many of my public talks, remember there's a transitional period. The atmosphere isn't a finger snap. It's just, La Nina, I'm going to start, everything's just going to change like magic in the atmosphere. It doesn't. There's this transitional period where things get readjusted to new patterns. And I just gave a talk in the Twin Cities last week. And in there, I mentioned, so many people had this anticipation, but this transition period is sometimes 2 to 4 months. What is 2 to 4 months? In some ways, it's a growing season. And so I deal more with ag than anything else. And then I go, and I even told you this winter, it's not magic. It's not a finger snap. And so part of the, I think sometimes when people thought, because I get grouped in, I'm sure you do too. Well, all you meteorologists are bad. You only have to be right 50% of the time. We have all heard the jokes, and I can laugh at those jokes. I understand where they're coming from. But a lot of times, I had this conversation last week too, is about, someone asked me and I said, you can believe me or you don't have to believe me, but, this is just 35 years of experience that probably 3 times out of 4, when someone thinks my forecast was wrong, it wasn't. They just weren't listening. They heard what they wanted to hear in a sentence and not the whole thing. There's this whole concept of, my wife and I were discussing this weekend, and I go, sometimes we're watching completely separate movies. We're seeing the same thing, but you're watching this movie and I'm watching this movie, but it's the same movie. And we're taking 2 different perspectives on things. And sometimes with weather, you hear, I might say, of course there's going to be a spot or 2 that's dry, but, most areas are going to be wet. And then people say, well, I thought you said it was going to be dry this summer. I go, no, I didn't say that. I said most areas are going to be wet. It's that they took one key word out of a sentence and it wasn't my point of the whole thing. And that times happens quite a bit. And I know, in fact, that has to happen to you in your world.
Oh, yes. Yes, it does. Although I try and preempt them by being the first person to criticize my own views and thinking about how I could be wrong. So I actually am impressed when somebody tells me that I'm wrong about something and I haven't actually thought about it, because I'm also my own worst critic, which I'm sure you can relate to as well.
Yeah.
Because I know when I'm wrong well before anybody else knows that I'm wrong, and I at least try to be the first one to raise my hand and be like, hey, that was not so. Let's try that one again. Let's run it back.
The short-term forecasts, which I don't do quite as much anymore, but a lot of people ask me. It's just not as public. But I'm always amused where I go, we should see widespread thunderstorms tomorrow, for instance. And maybe we get one, and it's not widespread. And people will call me and go, geez, your forecast is just terrible. And I go, I know that. I live with my forecast too. So it's like they have to tell you like you don't know. And I always I hope people have a sense of humor back when I go, because I try to keep my tone of voice relaxed and joking with them. And I go, oh yeah, I wasn't listening to myself at all. I didn't know I was wrong. Of course you're wrong, but it's all fun in the business that you're in.
Yeah. Well, but before we talk about El Nino, which was the elephant in the room, so what was the 30% that you felt like didn't quite align for you this year, and what are your expectations for the remainder of the year? How have you course corrected on that?
I think really in the upper Midwest where I live, the dryness in the I states, as they're oftentimes referred to, Iowa, Illinois, Indiana, there was so much anticipation with, El Nino, they should, or usually, those code words in there, should have had a wetter season. And I would, number one, in my last talk I gave, just a few days before this airing, us having this conversation was, no, there really is not a correlation in the Midwest with summer precipitation and El Ninos. It's just not there. People think they see it, or they'll remember one year where that happened. But, we've had a lot of El Ninos in the last 100 years to go by. And they're just, the correlation is just not really there. And so in a lot of those areas, I did have drier than average, or at least best near normal, and been drier. But it's been more up in the northern plains where I thought it would be wetter. It's been extremely wet over about, maybe a 60, 70%. I used, 70% before, but 30% has just been really, really dry. It's just the thunderstorms. We've had so many thunderstorm complexes, but they've hit the same spots every time. They've just gone over the same area. So we have quite wet and quite dry and not too many people in between. So that really is that 30%. Why I said at the beginning, in many ways, I was right. We had a lot of thunderstorms. We had a lot more action than we've had in the past few years. Yet there's this 30% that just, my goodness, like they have a force field, over them. A farmer called me over the weekend and said, we have this, and this coming. Hopefully you would think you would get hit by one of them. Yeah. And we'll see. But you just can't, that part of the county or that county just gets missed on the storms. So a lot of it, again, is, it's been more active, yet the activeness has been over the same areas, has been a little bit more of the frustration for me.
And what are you thinking about for the rest of the year? Like going into the winter, for example, do you think it's going to be colder in the United States? Are you thinking milder? Where are you sort of thinking about for 6-8 months from now?
I even think in the last podcast, because many of your audiences probably only knows me from that one podcast I've done with you. And almost every time I speak, I always tell people X does not equal Y. And a good example of this was really the last El Nino of consequence we had in the United States was 15 and 16 winter. And California was in a drought at that point. And the anticipation was, because El Ninos oftentimes, not always, will bring better rains to California, that it would be, really resolve their dry problems with a good wetter than average winter that year. And it absolutely did not rain that winter in California. It was just like, wow. And then the next year there was a La Niña, and at the time it was Governor Brown in California. And I'm not picking on him, okay, at all in this statement, but he goes, well, the drought's permanent. We're never going to get, it's just a permanent drought because there's a La Niña coming that's going to exasperate our dryness. We're just doomed. And he didn't say all of that, but he did say the drought is permanent in his comment. Well, then the next year with La Niña, when everyone thought it was going to be a dry winter in California, outside of this winter that we just went through in California, that year, that next winter was really, really wet and really resolved their dry problems for a while. And it was the exact opposite of what happened. And because it's X doesn't equal Y, there's clearly was more going on. You just can't take, well, La Niñas mean this, so this is going to happen. And so I start answering your question with that, because this winter, I think especially areas east of the Rocky Mountains will have your more typical La Niña pattern. The south is cooler and wetter than average, and the north is drier and warmer than average.
Typical La Niña pattern or typical?
I'm sorry, El Nino. Thank you. If you say them back and forth.
Yeah. No.
I'm going to make that mistake. Thank you for that correction.
I thought you were testing me.
Well, thank you. Seriously, when I get corrected on that you say those terms too quickly. But I think it will be that more classic El Nino winter pattern. Whereas, say, where I am in the northern tier of the United States, will probably be warmer than drier than average. Whereas you in the southern part of the United States will probably have a cooler and wetter than normal winter. You'll still have a nicer winter than me. But I think it will fit that. It's the West Coast that I think might not fit that. I don't think California this year will have an abnormally wet winter like you would anticipate with an El Nino. So that would be 2 in a row for that. Right. If it happened, that might be the exception to that more, say, traditional pattern over the United States. But I think the southern plains, the southern tier of the United States, and if that's the case, then that kind of traditional fall severe weather season that the southern tier of the United States east of the Rocky Mountains can oftentimes get might be a scenario this upcoming fall. And again, perhaps a little bit next spring, briefly, early on, say February, March. Core winter still for me, but more spring-like weather in the south. I think, again, that type of pattern will probably actually occur this year.
And that holds for the Northeast too? So cooler, wetter in the Northeast?
Well, the Northeast precipitation impact over the Northeast, it really depends on who you look at, but a lot of times tends to actually to be a little bit drier than normal in the Northeast. Because, again, that main storm track takes over, and then in turn is a southern, say that subtropical jet gets energized. Because of El Nino, that warming energizes the southern subtropical jet, as it's oftentimes referred to. And so in turn, you get this split flow. Think of it as two highways in the sky. And that's where all the action is where all the gas stations are, all the eating places are along this. And so one will go up through Canada and then go into far northeastern New England. And then the other one will slide along the west coast through and then hit the southern tier of states. So the southern plains through the southeastern part of the United States. So that type of pattern, in a way, leaves the Midwest and New England a little bit drier. Mm-hmm. The thing is, it only takes one nor'easter to go up the coast, and you get your yearly annual snowfall. And that's always the problem with snowfall predictions. Precipitation predictions are easier. But, one storm in a lot of these cities will exceed their winter average on it. And so that's always a possibility. But I really think that would be a more typical scenario moving forward for this upcoming winter. To me, that's a more typical precipitation pattern for the United States than the Northeast being wet.
Yeah. Okay, let's talk about the elephant in the room. And I'm going to stand in for my listeners here too, because I don't think often people know what this is. Tell us, and I know that this is probably painfully simple for you, but tell us first, before we get into it, what is El Nino? What do those words mean? What does it mean about the highways in the sky when El Nino is governing the traffic lights?
Well, there is a very simple answer to this, but I want everyone to understand that we don't understand it completely. The simple answer is the warming of the equatorial Pacific Ocean. So by definition is when the equatorial Pacific Ocean, generally east of the international date line, so central in the eastern Pacific Ocean. So anything west of the international date line, that area is the water is almost always warm and doesn't fluctuate so much. And by warming of the equatorial Pacific, by definition, it is 0.5, so a half a degree Celsius or warmer over a 3-month period of time. Mm-hmm. So if you're looking at definitions, it's not today, or it's not a month, it's not 3 weeks. It's a 3-month average is how it's computed moving forward. So if you're in the imperial system, which probably a lot of your listeners are, then think of it as 1 degree Fahrenheit. It's close enough, but it's a half degree Celsius. And so then this gets divided up. How warm is it? If you're a half a degree to 1 degree Celsius warmer than average, it's usually referred to as a weak El Nino, or if it's the opposite, a weak La Niña on the opposite, but we'll just stick with the El Nino term. And then if you're 1.5 degrees warmer than average, they usually refer to it as a moderate El Nino. And then usually if you get to 1.5 out above, and especially 2 and above, it's considered a strong El Nino. And the last one we had really of any consequence, because there's a really weak one that didn't last long just a few years ago, but the last one that really made the news a lot was the 15-16 winter one. Mm-hmm. That one was actually a very strong one. You could, I don't like the phrase, but you could almost call it super El Nino, which gets thrown out sometimes, but it was a very strong El Nino. This one, most computer guidance doesn't make it as strong as that one, but again, modeling the oceans is tough. You have to always think as computer models as guidance. Mm-hmm. It's I don't see how we're not going to have a moderate one. I'd be surprised a little bit. Not much surprises me in the business. But I wouldn't be surprised at all if this turns out to be a strong one. Just the odds favor it being weaker than the 15-16 one on temperatures. And of course, you always have to remember, most of us have cooked something in our life. It takes a lot of energy to heat up water.
Yeah.
And it takes it takes forever for that water sometimes to cool down. And so if you're going to warm up that massive amounts of water, it tends to be, that's a lot of heat released into the atmosphere, which in turn alters patterns. So with El Niños, you'll see certain areas of the world will dry off a little bit. Certain areas will get wetter. Certain areas will cool down. Certain areas will warm up. And that's an overall average. But again, every El Nino is like its own little robot. It kind of does its own little things. Every one is unique. And so when you read headlines and stuff, you can't take it as, that's going to happen. No, you can't take it that way. What they're saying is, this area is the key word here, usually. And what is usually? Maybe 2 out of 3, 3 out of 4, somewhere in that range. But there is certainly 1 out of 4. And I already gave you a classic example from California in 15-16. They did, in this past winter, for instance, La Niña, and they got just like record-breaking snows and rains in California. And again, but if you take that over 50 La Niñas, it's still it's going to end up being drier than average anomaly. But again, every year is unique moving forward in time. And so you just have to remember that when you're reading articles, no guarantees in the future.
And you alluded to this, that there's a transition period. Are we out of the transition period? Are we still in the transition period to El Nino? Where are we there?
This is one of those, you could talk to 10 meteorologists and get 10 different answers, not to pick on my profession. So you're just asking me. I think we're still transitioning a little bit, but I see us going to more, transitioning into more, quote unquote, a vast majority or a majority of El Nino type patterns. But again, in the United States in particular, North America, El Nino's influence is far more in the fall, winters, and early springs than it is during the core of the warm season. It's hard to find a correlation in the core of the warm season like we are right now. But I think as we transition moving forward, we will see it. And I think that signal will be pretty strong this winter. And again, my current anticipation is it to be one of those 2 out of 3 or 3 out of 4, winters. And we see, the north warm, the south cool, again, per average.
Yeah. And then I want to come back to that in a second, but before I do, and correct me if I'm wrong here, I feel like one of the things that was so strange about the last couple of years was we had triple dip La Nina. We had 3 consecutive years of La Nina, which seemed to be a little bit out of what was normal. How long do El Niños last? Do we get a double dip thing, or is this, as you sort of said in 15-16, is this like a 1-year thing? Is this just a 2-season thing? Like, how do we benchmark how long we think El Nino is going to be with us, and when the shift might happen away from it?
Well, let's just go back to 1950. So that's 73 years, because that's when we have decent data. I wouldn't trust all of it because, there weren't satellites in space in 1950. And at the beginning measuring this. So it's still not really an apples to apples thing, but we have at least a rough idea from 1950 moving forward. A vast majority of the El Niños have just went poof, poof, and gone. They'll peak in December, and this one might peak in December at thereabouts. That's why it's called El Nino. Really goes back to the Christ child, because they would peak around Christmas time, and that's kind of where the name originally came from, because El Nino is the boy child. La Nina is the girl child. The exact opposite really is why that name was chosen. And then I think by next summer it's gone. Probably by the Memorial Day next year, that we won't be in an El Nino anymore. So it'll be really like a 1 year, say June to June event. And if you look back through time, a vast majority of these, especially, it seems like the stronger the El Nino, the shorter time frame they lasted, because they really peaked and fell. Whereas La Niñas, you talked about the triple dip. We've had a triple dip one in turn of the century, about 20 years ago. Before that, we had a triple dip one. In many ways, you can equate it into the 1980s in a way, 20 years. Then we had one in the 70s, which is only like 10 years. And then we had one in the 1950s. So it seems like the triple dip La Niñas in the last 70 years have occurred approximately every 20 years. And again, a vast majority of the El Niños, though, tend to be stronger. So you get a stronger positive temperature than you will a negative number for La Niñas. But they're a shorter duration. So, just based on history, not necessarily a forecast, but based on history, I would anticipate this to be done. And next summer in the Northern Hemisphere, say in the United States, we will be back in neutral conditions, which means neither. You're either not in an El Nino up, you're not in a La Nina down temperature-wise, you're in what a lot of people refer to as La Nada, which is a made-up term, just nothing. You're in the middle someplace. So that's what's interesting is a high percentage of the time El Niños are much shorter lived than the opposite La Nina because, looking back at time, I can't really find like a triple dip or a 3-year El Nino. You can find a couple, but usually, 12-ish months and they'll start fading away. And my suspicion is by next June, this one will not be with us anymore.
Yeah. I'll ask a slightly personal question here, which is personal for me, which is, we're sitting here in the Gulf. One of the shorthands, I feel like when it's written about El Nino, you let off with X does not equal Y, but they love to make X equals Y here because it's all, La Nina means warmer temperatures, means more Atlantic hurricanes, but now we're in El Nino, so maybe fewer Atlantic hurricanes in hurricane season. So tell me why, just react to that. I'll let you riff.
Well, the thing is, El Ninos now, because of the warming of the Pacific Ocean, and then it tends to develop this flow aloft from the west to the east that's a little bit stronger. So if you're going from Africa to the United States, of course, you're traveling west. The winds aloft with an El Nino want to be traveling east. So it's really like you're in New Orleans and you're going to head over to, say, Houston, and the wind's blowing from the west. You don't get as good as gas mileage because you're bucking the wind the entire time. So when hurricanes like this season so far, the trivial little things that have formed haven't really lasted and have just run into, and what this is really referred to as shear, different wind speed, different wind directions at different levels, shear. So when these storms form, that's why most El Nino years, you have this tendency to not get as many hurricanes because they're fighting to really form. The waters might be warm. The Gulf of Mexico right now is about as warm as it gets, but nothing has formed yet there. Why? Warm waters. Again, it's one ingredient. You need more than just warm waters. And so the odds are in your favor. But guess what? There was a storm called Andrew. And that really was on the tail end of an El Nino. And think about it. Andrew was at the end of August. And granted, they didn't name every swirl of clouds in the Atlantic like they do nowadays. Andrew was the first storm of the season very late in August. We rarely go to August anymore, again, because they name everything that's the swirl. There's always arguments in the meteorological community. You should have never named that one. And historically, they wouldn't have. I'm not going to argue which way is the correct way of doing it. But I'm just saying it only takes one storm is always the issue with a hurricane. What if there's just one good hurricane that hits the United States this year and it happens to be New Orleans? The forecast of fewer of the hurricanes would be correct. But it's not correct to you, for an example. And so I always like just pointing that out to folks that, it's weather. It only takes one. Just because, someone's going to win the lottery. It's not going to be you, probably, but someone. And that's a sad thing. But, now we're getting into the peak of the hurricane season here pretty quick. The peak is usually around September 10th. So, really August, September into the middle of October, there's like 75 days there that we're going to get into here. Because this El Nino is developing fairly rapidly, you asked about the transition. That transition period is really over in many ways. And you can see this more typical thing happening now in the Gulf and to the Atlantic. That, again, if you're going to just, it's an odds game sometimes. The odds are that this probably be a much reduced season for hurricanes. And so if I was living along the Gulf, I would take, well, at least this year is probably a year will be fine, much better than say in 2025 or 2026 when we might be back in a La Nina or a little bit cooler, a little more traditional period moving forward. So that's, I think most meteorologists would probably say the same thing.
Mm-hmm. What parts of the world are more vulnerable then?
Well, with the El Nino, you may have noticed there, last couple of years with this triple dip, East Asia did not have a lot of typhoons.
Yeah.
And already this year, we've had a couple very impressive ones, super typhoons. And so it would be the Philippines, China, Japan getting hit, Southeast Asia. It would really be Eastern and Southeastern Asia that they would probably see an uptick in typhoons. And then, of course, disruptions associated with that. That would be, and their season never ends. It's 12 months a year, really, unlike most of the rest of the world. So that would be an area by far to watch the most.
Yeah. You mentioned just one ingredient. And I know that you've also, the last time you were on the podcast, and listeners, if you haven't listened to it, you should go back and listen to it. It was really excellent. But you've talked about how there are other cycles in the atmosphere and oscillations and this, that, or the other thing that also affect a lot of these weather patterns. So is there something about what's going on more broadly that could tell us something about how this particular El Nino will behave or will change it from past El Ninos? Is that question too vague or does it make sense?
Oh, it makes perfect sense. A lot of oscillations. One of the probably bigger oscillations that most people have never heard of. And truth be told, a lot of them, this type of audience has never heard of. But, in my world, I deal, not exclusively, but mostly with ag. I deal a lot with flooding because I live in a flood-prone area and some other things. But is this thing, they would have heard of some oscillation patterns. But one of them that many people I haven't heard of is this Madden-Julian oscillation. It's this thing of it very simple as a thunderstorm complex that circles the globe near the equator. And when you have all these thunderstorms form in a certain area, it also then has impacts around the globe. And so when these thunderstorms are in certain areas, well, for the next 2 weeks then, this area, say, is prone to be, you'll probably be warm and sunny and won't get any rain the next 2 weeks. Or, speaking of the Gulf of Mexico, when the Madden-Julian oscillation is in a certain phase where the thunderstorms, this circulation that goes around, gets into certain positions, that's when you're the most prone to get Gulf hurricanes developing. And we were actually in that back in June, and we never had one develop. And there are certain meteorologists and certain things I follow going, Madden-Julian oscillations in this pattern. The Gulf of Mexico is really warm, but there is an El Nino kind of there. What's going to happen? And fortunately, nothing happened. Yeah. But, and I don't know if anyone publicly much that the general public was aware of that. But, in certain meteorological circles, I was one of them just going, curious. But see, it's not a guarantee, but but that pattern is usually a lot of times only 4 to 6 weeks out that helps you. So for me to project the winter right now, that oscillation pattern doesn't help very much. One of the oscillation patterns that might help a little bit is I don't know if I talked with you the last time, it's this quasi-biennial oscillation. It's a stratospheric oscillation pattern that has, I used that this summer for some of my forecasting and it worked really, really well this year on some of my worldwide projections. But that's another oscillation. That's one that lasts longer. That usually is a couple of years. We're in a certain oscillation pattern. But again, it's such a short term, some of these oscillation patterns, that it's hard to project out 4 or 5 months. But it helps you in the next 2 or 3 weeks sometimes that, hey, we're favored for this development during this time frame. But there are a lot of oscillation patterns. As I just call them, a lot of alphabet soup. Because they all, MGL, the NNA, the AMO, the PADO, you can just go on and, there's all these oscillation patterns that are out there. And what I do for long-range forecasting is I put them all together and go, well, the last time we had these 4 things going on at the same time, that summer, this area was wet. Why wouldn't it be this time? And usually that works the 3 times out of 4, which is useful, but it's not perfect.
Yeah. Let's think a little bit long term here. So, I mean, I'm sure that like politics, this is an inexact science, but if you're thinking about sort of the next 10 years of weather developments, and there really is a lot of doom and gloom out there about this, which relates to the whole climate change thing. We don't even have to go on that political landmine right now. But how do you think we'll look back in time about 2023 over a 10-year sort of time horizon?
I have been saying really back in 2006, it was a fairly dry summer throughout much of the United States. And many areas had been pretty wet for the previous 10 years leading up to that. And, a lot of times people like to use the phrase wet cycle. We're in a wet cycle. I really don't like that phrase at all. I go, no, we're in the wetter phase within our climate. Because most climates, wherever you are, you go through wetter phases and drier phases. And we have since the end of the last ice age with proxy data. It's very clear. And a cycle is, this is going to happen on a perfect rhythm and it's a clock, and it doesn't work that way. And people will try to come up, and you probably have heard of them. Well, we're in this 187-year cycle, and those types of stuff. And you look back at time and you go, but people take it kind of too literally. I go, I'm not denying that there's some like oscillation there, because all these things are like, because El Nino and La Niña's technically term is ENSO, N-E-S-O. El Nino, Southern Oscillation is its official name. Oscillation. I always think of it as waves, oscillation going forward. And so based on that and proxy data back in 2006, I had a lot of folks come up to me, go, geez, Daryl, this wet cycle we're in, again, don't like the term, they used it. I bet it's over with now. And I go, no, I don't think so. Because if you go back and look at proxy data, because proxy data is awful, in my opinion, on temperatures, but it does a good job with precipitation, because it's more, it's a more substantial, it does stuff. Lakes fill up and lakes go down. And you can do proxy on that. What makes a lake go up? Well, more rain. What makes a lake go down? Less rain. It's kind of obvious stuff. And so the proxies for that work pretty well. I don't think we'll dry off until the 2020s into the 2030s. And oddly, I was saying that for years. And then in 2017, when we were not much of the United States, but my area, North Dakota in particular, was very dry summer. Oh, geez, Daryl, I think this is for sure the wet cycle's done. You've already said the 2020s. I've been listening to you for a decade. You keep saying this. I go, well, it's not the 2020s yet. It's only 2017. And then I made, most people have heard this. How do most droughts or dry periods end? With a flood. There's the old saying, all droughts end with a flood. I told them, oddly, if you look back in history, a lot of wet phases ended up with a flood. Then it went dry. And people just kind of laughed and go, Daryl, that's just crazy talk. Well, in 2019, we had just massive rain in the Midwest, massive flooding. And then I told people, guess what? Now we've done it. Now we're going dry. Well, let's see what happens. And we've been dry ever since, for the most part. Still rains. And so that's background to say this. I think the 2020s and the 2030s, much of this, especially the United States growing areas, will probably see far more years with average or below average rainfall than above average rainfall, which is the exact opposite of really what's been happening in the last 20, 25 years. And it's an oscillation to me. I don't know what to call the oscillation. We could call it the Jacob oscillation.
No. We're definitely calling it we can call it the Jacob Shapiro oscillation if it's wrong. If it's correct, it should be the Daryl Ritchison oscillation. I'll do you that solid.
But that's, based on historic proxy data. And then people go, I'm not, as you already know from the beginning of this podcast, I'm not a scaremonger when it comes to weather. The weather is wet. I just not one of those people. I never have been since the beginning of my career, which has made some news directors people need to hype this up a little bit more. I'm just not that kind of person. So then people go, oh my, like the 1930s coming back. And I go, oh, I tell you, the 1930s will come back at some point. It wasn't like the first time it ever happened. But I go, no. If you think about it, the 50s, 60s, and 70s, most years were a little bit drier. The lakes started to shrink. It was a little bit drier. We still grew crops. We didn't probably get as much moisture. We have better genetics now. There's positives here. All I'm saying is we're going to go back to, say, the 20th century average of precipitation rather than the last 30 years of average. Because if the new climate average, if you watch wherever you're listening from, if you go, the average rainfall is, 9 inches for June. Where does that come from? That comes from 1991 to 2020. Those 30 years is where that data comes from. During those 30 years, that average for June was, say, 9 inches. Where I live, it's like 4.25 inches. Mm-hmm. Historically, our June average was closer to 3.25. So during this wetter phase within our climate, which has happened multiple times in the last 5,000 years from proxy data, we gained an inch of rain. So what if we go back to 3.25? That's what I'm talking about. We're going back to that long-term average. So there's being a little bit wetter, having problems with water, having more floods recently will fade away. And I think a good part of the United States will trend drier, especially where we grow most of our crops, our row crops will trend drier. And if you think about it, over the last 2 or 3 years, that really has been the trend. Look what's happening in Iowa, Illinois. More talk lately has been we need more rain than we have too much rain in the last couple, 3 years. Every spot's different. It's a huge country. We're talking millions of acres of that we plant. But that's what I think, you're speaking in Fargo for the next 5 years, coming up in September. Looking forward to it. And it'll probably be online for the rest of your audience to hear after it's done. If I was speaking on the next 5 years or the next 10 years, I would go and show you statistics, proxy data, why I think we're going to go from our average precipitation now, that new 30-year average that just started, and let's call that 100%. Okay, that's 100%. Where are we going in the next 5 to 10 years? I'd say let's get used to 80%. Because I think that's where we're going. Not going to be a catastrophe. I guarantee you at some point, the United States is so long overdue for a drought. From a historical perspective, it's going to happen. It's not if, it's when. 2012 was really the last time we had a widespread drought in the United States. We had dry pockets, but not a widespread area. At some point here, even this decade, that's likely going to repeat itself. But that's just a sign of, to me, in the next 5 or 10 years, we're probably going to see a few more drought years than, say, we did in the 90s, early 2000s, when we had a lot of years where really excessive moisture was a problem. Speaking of like last year, what happened to the Mississippi? Barge traffic, less water, those types of things. If you want to call that climate change, you go ahead. I just call it fluctuations within our climate.
Yeah. Does temperature map onto that as well, or temperature is a whole different can of worms?
Temperature gets to be a whole different can of worms, but people will laugh at this and go ahead and laugh at it. I would think we might see a subtle cooling after this. El Nino will spike things up a little bit, of course, because you're warming up a lot of water. It's kind of like things spike down a little bit with La Nina that we had. But the United States has been, generally less extreme than we've been in the past. We don't see these massive 100+ degrees like when I started this off, like what happened back in 1950, and there's been other years in the past, is that we might actually trend a smidge cooler in the row cropped areas in particular. That, say the Midwest in the traditional times is sometimes referred to as, say Ohio to North Dakota, Nebraska. Sometimes people throw Missouri in there. That north central core might trend a smidge cooler. Might be imperceptible, but I'm not really worried about the heat, except on dry summers tend to be warm summers, just because dry soils heat up more rapidly. Without the water in the soils, you heat up the air temperatures. Why the 1930s, parts of the 1950s, we had these just ridiculously, stuff that most humans in the United States, most people in the United States never experienced stuff that happened in the 1930s and the 1950s, and to some degree a little bit in the 1970s. It's just been so long since we've seen something like that. So there might be that oddball year, but again, I don't think temperatures are going to fluctuate much. If anything, might be down a smidge, but again, it would be imperceptible. That's just my way of saying it's not something that overly concerns me at the moment, except that one, especially that one summer we have a big drought, which I'm sure we will have. I'd be surprised if we didn't. Sometime here in the next 5 to 8 years, that summer will probably be a warmer than average summer just because there's very little moisture. And again, we have millions and millions of acres plowed up by man. That's all prairie or forested 200 years ago. So when you expose all that black soil to the sun, like what happened in Illinois early when they're setting some really records very early on, that's 100 years ago, that was either forest or prairie. We wouldn't have experienced that. We were just, all that energy is being absorbed by that black soil. And that's why a lot of times, it's more so now than even in the past, when you do get a dry summer, you're going to get a hot summer with it. One oddity, really, when I talk to people in Iowa, Illinois, in that area, I go, you've been dry. Not going to deny that. The odd thing is you've been dry and not above average.
Yeah.
So that's a net positive for them, was at least you aren't baking in the heat, because the upper air pattern just wasn't very conducive to that for them. And that was the only good news you could take from their dryness, and in many cases still dry to this point.
To your point about the 1930s, I'm halfway through Ken Burns's documentary of the Dust Bowl, and I was just thinking to myself when I was watching it the other day how it would get how that would get covered today in the current media environment, because even some of the pictures and clips and some of the things that happened in the Midwest around that time period, it's apocalyptic. I think people would probably freak out today. I don't know. I think the coverage of that would be completely wild.
But you do have to remember we have many soil conservation service things going on now that we probably, if that exact pattern happened over the United States again, and I would be very surprised, maybe not in my lifetime, but at some point this century, we're going to have 3 or 4 year, 5-year drought like that, is that, we have ways of transporting water now that they didn't have that. They're more irrigated water that we could use, things that can control that. But at the same time, most of you will remember this. Look at that horrible event in Illinois with the dust storm and the traffic and all those people that died. And that would be things that happened in the 1930s. So sometimes, because we haven't had years like that, our memories are short. Well, why do I have this shelter belt of all these trees here? If I tear all that down and plant it into corn, there's X amount of more money I'm going to make next year. And so are we forgetting the past? And then how good will our soil conservation be? But I can't fathom it ever being that bad again because of modern technology. But at the same time, it will be bad because Illinois, just that one small example, is something that would happen more frequently.
Yeah. Daryl, I'll get you out of here on this. I know you focus mostly on North America, but I want to take the liberty of asking you about Europe. So it seemed like the weather gods were aligned against Vladimir Putin last year. Europe had a very, very warm winter. It allowed them to pivot away from Russian natural gas, but I can't believe it's already July 2023. The war is still ongoing. The natural gas flows are still less. Europe will have to find heating this winter as well. And here at the investment firm, we are long natural gas right now because we think that natural gas prices have gone too low and that we will see increased demand. Should I be worried about that? Do you think that Europe will have a warmer winter? Are there cooler temperatures on the horizon? Talk to me about your outlook for Europe over the next 6 to 9 months.
Here's a big favor from Mother Nature for Europe. Statistically, or using long-term trends, there's 2 things in favor. Last year there was 1. This year there's 2. Actually, last year there was 2 also, but if you throw in the QBO, the quasi-biennial oscillation, gave a warm tendency to Europe, as well as the AMO, the Atlantic multi-decadal oscillation. And you may have, a lot of people were just, oh my goodness, look how warm the waters are off of Great Britain. And they're way above average, but they're still in the 50s, It was still get hypothermia in the water, but it was above average, no doubt. But here's the thing. El Nino's impact in Europe, especially early winter, say October, November, December in particular, is a warm tendency statistically, if you take all El Nino. So that would be, say, the first half of their cold season. Number two, the Atlantic Ocean is still in its positive phase, its positive AMO, which leads to long-term trends. And I think we discussed it the last time in our podcast. So winters have been almost all warmer than average for the last 20, 25 years. Well, the AMO's been positive for the last 20, 25 years. And it will likely switch this decade. It's about a 30-year oscillation pattern. So that might be a 2030s problem more than a 2020 problem. So that's two factors now for Europe to have a warmer than average winter. The third factor is the QBO. So there's three reasons this year to believe, but again, TUV doesn't equal whatever you want, doesn't equal Y either. Three things, there's still exceptions, but that's three favorable things for them to have a positive in Europe. Now, Scandinavia has a cooler tendency with El Ninos, especially in the second half of winter. But when El Ninos are really, really strong, that statistical anomaly goes away. And then there's not a trend. So if we're in a moderate El Nino, then you might think, okay, Scandinavia, the first half, warm tendency, the second half, cool tendency, especially for far northern Europe and then Scandinavia. But if we end up with a strong El Nino, that turns off a little bit. If you're really, the correlation turns off a little bit. But again, there's more reasons than not to believe that yet another winter. Will they have cold snaps? Yeah, it's still winter. They'll still have cold periods. But if you take, their 4 or 5 month cool season, November through March, I would put, I don't play the futures. Don't use anything I say to play the futures. But I would think there's a lot of statistical reasons to believe that they will get through this winter like they did last year as well, with temperatures maybe at least 1 or 2, maybe even as much as 3 in some spots degrees Celsius, not Fahrenheit, above average. And if you want to use Fahrenheit, that'd be 3-5 degrees above average overall. I mean, there's a lot of countries in there and a lot of territories. But Jacob, there's just, again, global weather patterns. There's a lot of stuff in their favor. But again, who predicted California to have their wettest winter on record pretty much last winter? I can tell you there was this many people. That's a big zero. You can see it, the podcast won't. So you never say never. But I would, if you wanted to use statistics, with these three positives in there, I would say there's probably at most maybe a 10% probability that they would have a cold. And if they do, I bet you it would be slightly. Again, there's just so many factors this winter. If I would respect anyone that said, give me 5 reasons why they're going to be colder than average and be right, I'd really respect that person if they nailed it, rather than just being luck of the draw. They gave 5 good reasons and they all came true.
What about precipitation for Europe? Because you mentioned the Mississippi River. The Rhine has also been very, very low. German industry's been struggling with that. Is it warmer and drier, or is it warmer and wetter?
Generally speaking, that warmer part in the early part of winter, especially much of Europe, including the Rhine, would have a tendency from, I'd say, late summer, say Labor Day through Christmas at least, statistically to have a little bit more of a wetter pattern as well as the warm. Because sometimes they can equate. You're just getting more transportation. The Atlantic's warmer than average right now. So there's reasons to believe, that you would get above average. But here's the thing. It's not their peak necessary. What does above average mean in certain times of the year? That's not when that's their wettest time of the year. Sometimes, being above average doesn't necessarily mean that you're going to solve your water problems. Yeah. But there are some positive thoughts there that at least they would be able to maintain the status quo or do a little bit better than that. But again, it would be the first half of winter. And it really, I think even, most people think of summer ending with the autumnal equinox in September. September is really an autumn month. So I would say, late August through early December in particular, if you look back historically at El Niños, you would find, especially France, Spain in particular, anything kind of west of the Alps would be a little bit more prone to above average precipitation in those areas.
Anything that I forgot to ask you, Daryl? Anything else you want the listeners to know?
I would, if you're really interested in ENSO, I would just do a quick, I'm not a big fan of using Wikipedia because there's so many things that get adjusted in there for political reasons rather than real reasons. But most of those will give you a pretty good understanding. We never really went in, and it gets pretty complicated. And, we don't, and by we scientists, the weather community and stuff, don't completely understand why El Niños and La Niñas, that oscillation, what impacts them, and things like that. But there are some good materials if you're interested in a little bit more on the formation and what happens. Just do a quick search, and within 5-10 minutes, just read a couple of articles. You would get a little bit more in depth of that subject than I think you and I covered today.
Okay.
And truth be told, it's hard verbally. It's easier visually to see it. And so there's some good stuff online. So just as a hint, if anyone has a little bit more interest, go online. There's some nice videos I know and animations to describe the process for everybody.
Sounds good. All right. Well, Daryl, we'll have you back. We'll have you back soon. And otherwise, thanks for taking the time. We appreciate you.
Hey, you're very welcome. I'm going to be really honest with you as we end, Jacob. That I thought, wow, he wants to kill an hour on El Nino. I don't know if we can do that. Well, we did easily. I should have known better.
I always, one of my favorite quotes is from Blaise Pascal, which is, I didn't have time to write a short letter, so I wrote a long one. I think it applies to podcasts as well. So happy to have you, and we can fill up a lot more time too, but we'll give the listeners a break. Cheers. Thank you so much for listening to the Cognitive Dissidence podcast, brought to you by Cognitive Investments. If you are interested in learning more about cognitive investments, you can check us out online at cognitive.investments. That's cognitive.investments. You can also write to me directly if you want at jacob@cognitive.investments. Cheers, and we'll see you out there. The views expressed in this commentary are subject to change based on market and other conditions. This podcast may contain certain statements that may be deemed forward-looking statements. Please note that any such statements are not guarantees of any future performance, and actual results or developments may differ materially from those projected. Any projections, market outlooks, or estimates are based upon certain assumptions and should not be construed as indicative of actual events that will occur.